Later on, those who cannot log in, come and see me. My lessons end at 2:15 today. So you can come to staff room 1 and find me. Okay? Now, sine rule. Let us turn to your textbook, page 54. Page 54. We have a triangle at the bottom. Remember, we use this triangle, we call the sides. Okay, the different points of the triangle, A, B, and C. We use capital letters for the points, the vertices, okay? And what do we use for the length of the sides? For example, this side, CA, what can I call it? Small b. Okay, what about this side? Small c. This side? Small a. What is this angle here called? We can call it big C, or we can call it BAC, or we call it big C, or BCA, or ACB. Okay? If it is clear that there is only one angle, you can just call it angle C. Sometimes it is unclear which angle you are referring to. That's why we call it BCA or ACB. Okay. So now, our sine rule states that, this is important, it is also highlighted in your textbook already. A over sine A. Okay, this is a fraction. Small a refers to the length over here, divided by sine of this angle. Okay, A over sine A is equals to over here, B over sine B, where this is the angle for B. Okay, hold on, which is also equal to C over sine C, where this is C and this is our angle C. Okay, this is our sine rule. Okay, now let me break this down for you. Please watch. Now I have three terms that are equal to each other. I can write also A over sine A is equals to C over sine C, right? The first and the last term, they are the same. They are all the same. I also have A over sine A is equals to B over sine B. They are the same thing. And of course, I also have B over sine B is equals to C over sine C. Okay? Basically, they are all the same. How is this useful for us? Whenever you need to find an unknown side or an unknown angle, and then you are given two angles and a side, or two sides and a non-included angle. This is found at the bottom of page 54. You can use your sine rule. Okay, so find this in page 54 and highlight it. Sine rule is very useful, and we're going to see how we can use it. Now this triangle that I've drawn over here, is it a right angle triangle? It is not a right angle triangle. Your sine rule can be used for any triangle. Does not have to be right angle triangle. Okay? So let us look at example 10. On page 55. I have a triangle A, B, C, 40 degrees here, 60 degrees here. This side I have 8. And this is little c, little b. Okay, find the side B and C. Okay, so we are going to use our sine rule. I am going to attempt to find B first. Okay, what does our sine rule state again? The length, any length over sine of the angle opposite it is equals to any other length divided by sine of the angle opposite it. Okay? So now I have a side over here. I have an angle opposite the side. So I write 8 over sine 60 degrees is equals to any other side. Okay? Let us try B first. Equals to B over sine what? Sine 40 degrees. Okay? Any questions for this step? Yes? This is a direct application of the sine rule. We are using a side, okay, in this case side BC divided by sine 60 degrees from our sine rule. This is equals to another side. Choose any side you like. In this case I chose B divided by sine of the angle opposite it, which is 40 degrees. Yes. Yes. Kind of like it, but 7.2 we were dealing with. 7.2, what do we have? We have the area of triangle. Yeah, this triangle diagram is the same as what we use for the area of a triangle. Okay? So now I have an equation. I need to find B. What should I do to both sides? If I want to find B, I need to times sine 40 degrees. Yes, times sine 40 degrees. So I get B is equals to 8 sine 40 degrees over sine 60 degrees. Answer? 8 sine 40 divided by sine 60, we get 5.9378. That is rounded off to 5.94 cm. Okay? So B is 5.94 cm. Okay? Now, we have one more side to find. It is side C. How to find side C now? I have two sides, I have two angles. More than enough information to find. Can I use Pythagoras theorem? Who say yes? Sure not. It's not right angle triangle, you cannot use Pythagoras. So how? Sine C. But what is sine C? I don't have the angle. So I need to find this angle first. I need to find this angle. We can find it easily, right? The sum of angles in a triangle is 180 degrees. So angle C is equals to 180 degrees minus 60 degrees minus 40 degrees. You get 80 degrees. With this, I can apply my sine rule again. So 8 over sine 60 degrees again equals to C over sine 80 degrees. Okay, this is after applying our sine rule. And therefore, C is equals to 8 sine 80 degrees over sine 60 degrees. Our answer will be 9.09 9.72. Rounded off to 9.10 cm. Okay? So now it is time for you to try. Try it 10. I recommend that you sketch out the triangle first, so that you know which angle is opposite which side, and how you can apply your sine rule. Yes, Irfan? Same format. Now. Okay, shh. Do your work. Are you doing? Are you doing your work? Okay, now I am going to sketch out my triangle with the information given. So BAC is 100 degrees. I'll just sketch out a 100-degree angle. BAC. This is 100 degrees. Just join it up. Rough sketch only. Don't need to be to scale. So AC is 16 cm. And what else do we have? ABC 50 degrees. ABC, this is 50 degrees. So I know the angles in a triangle, they must set up to be 180. So this must be 30 degrees. Okay? Now I need to find the sides A and C. Where is A? A will be over here. And C will be over here. So using my sine rule, I have a side already. So 16 divided by sine. What is the angle opposite? 50. Divided by sine 50 degrees equals to, let's choose A. Okay, let's start with A. Divided by sine. What is the angle opposite A? 100. So you have an equation. I can find the value of A. Okay, so this will give me 20.569. Round it off to 20.6 cm. Okay, who got this value, 20.6? Wait, how? Do you get 20.6? Francis got it? Okay, so let us move on to find the value of C. Now we want to find this. So again, C over sine 30 degrees equals to 16 over sine 50 degrees. So C equals to 16 sine 30 over sine 50. .443, rounding off to 10.4 cm. You get this? Okay, those who got it, you already know how to apply your sine rule. Okay, so this is for two angles and a side that is given to you. So we are going to try the other type of question. It is when you have two sides and one angle that is not included, and one angle. Okay? Let us look at example number 14. In example number 14, we have 2 points A and B. Over here, this is 35 degrees. This is 56 degrees. Now find the distance AS. AS. How do we find this angle? How can we find the angle, the side AS? We are eventually going to use our sine rule. Afi, you said find SC. How do you find SC? I want you to consider all the angles that you can already find. Okay, what is this angle here? 180 minus 56, right? So that will be 124. Oh, this angle. Yeah, minus, you get 21 degrees. Okay, so now concentrate on this yellow triangle. In this yellow triangle, it looks like this. Okay? How do we apply the sine rule here? One side divided by sine of the opposite angle equals to another side divided by sine of the opposite angle again. So which side do we already have? AC. Okay, so 170 over sine what? Over sine what? What is the angle opposite 170? Angle S, right? Which is 21 degrees. Okay? This is equals to the unknown side, which is AS, divided by sine what? Sine C. What is the angle? 124. Do you have an equation? You can find the side AS. So AS is equals to, on both sides, we are going to multiply by sine 124 degrees. Then my answer will be 170 sine 124 degrees divided by sine 21 degrees. Answer is 393.27, which rounded off gives you 393 meters. Okay? Oops. So this is 393.27. Now find the perpendicular distance from S to the road, meaning they want to find this. SC. Okay, this one I can leave it to do yourself because you can just use, you have a right angle triangle here. Then you have the hypotenuse. You need to find the opposite side to angle 35 degrees. So opposite and hypotenuse, what should we use? Sine, yeah. So sine 35 degrees equals to SC divided by AS. And then you can find SC. Okay? Let's do some quick practice. Let's look at your exercise 7.3. That the thing S, is it? Doesn't matter, it's just something. It's irrelevant to the question. Okay, exercise 7.3, very quick exercise about your sine rule. Find the unknown side A. What should the equation be like? How do we find A? Form an equation. Practice now. Right? What should we have? What do we have? A. Yes, it is the homework. Okay, so A over sine 44 degrees equals to equals to 9 over sine 60 degrees. So you can solve for A to be something, round it off. Okay? So that's for part A. So let's see part B. Another triangle A, B, C, 49 degrees, 30 degrees, A, and 18. Okay, Natasha, can you come up with the equation for this to find A? Over sine A equals to Oh, sorry. Yeah. No, just tell me your sine rule. What do you get? Over sine? 30 degrees. Excellent. Now the question is, what is this value of angle A, right? How much is it? 180 minus 49 minus 30. That will be? Sure? 101. I'm not going to calculate. Okay, so instead of sine A, we're going to write 101 degrees. So solve for A equals to something, round it off to something. Okay? So this is how we apply the sine rule. Alright, your homework question will be 1A, 1B, 2A, 2B, 3, 4, 9, 11, 12, 13. Yeah, exercise 7.3. Okay? So these are super easy. These are okay. It is due on this Friday. Okay? Then I have students who owe me work, right? So you automatically stay back after your visit.